Greetings to you all our viewers. Welcome again to Talk to My Car, where we make your cars talk to you in a language only they understand. Please, when you have time, endeavor to visit our Facebook group forum where we discuss vehicle diagnostic issues into more detail, and where you can interact with us, ask questions, and have us ask you questions back. Today we are going to have a chat about the CKP and CMP sensors. CKP stands for crankshaft position and CMP stands for camshaft position sensors. Now, these are the major sensors that inform the engine computer or the engine control module about the position and speed of the engine. That is for the cylinder positions, crankshaft position, camshaft position, valves, all that. These are the sensors that the computer uses to know exactly where each of those components is, and therefore trigger the controls for fuel and spark delivery on the engine, and sometimes for opening things like EGR valves and stuff. The common types of CKP or CMP sensors are split into about 5. Some are more common than others. There's the magnetic, the magnetoresistive, the Hall effect, the read, and the optical. In our personal experiences at T2MC at Talk to My Car, we have interacted mostly with the magnetic type of resistors and the Hall effect type of sensors. I'll explain briefly how all these work. Basically, you have, say, this is the camshaft or crankshaft with teeth on the end, and let's say it's rotating in that direction clockwise, and we have these teeth and gaps, teeth, gap, tooth, gap, tooth, gap, and so on. When they are rotating, they come and pass near the tip of this sensor. Now, what's happening is this sensor has a magnetic tip. So every time a tooth on this wheel, on this rotating wheel, or it could be the flywheel, it could be the camshaft, of the camshaft, every time it comes and every time a tooth passes, it affects the magnetic field that is experienced by this magnet around here, and when it does that, it affects the way in which current sent into this sensor by the computer via these contacts you can see here. The current going through this sensor, the tip of the sensor, is affected by these wheels passing. For the magnetoresistive, Hall effect, and optical types of sensors, these will require power from the computer, but the other type of sensors, the magnetic, especially the magnetic, will not require power. They will generate their own power and send signals to the computer using the power, their own voltage that they have generated. The magnetoresistive, the Hall effect, and the optical, those have to get power from the computer, and basically what they do is they toggle that power on and off, and that's how the computer interprets their movement, or rather what they are sensing, because what the teeth and gaps they are sensing keep causing magnetic field that stop the flow of current and then let it, and then stop it, and then let it. And by reading that, the computer understands, works out how what position the camshaft or crankshaft is in, and therefore the valves and the cylinders, and then uses that in its calculations to actuate several things. VVTI on vehicles with VVTI on variable valve timing. It actuates sparks from the spark plug coils. It actuates injectors to deliver fuel at the right time to the engine, and so on and so forth. The optical sensor especially needs power, because the way it works is it's this tip, the tip here keeps cutting power. The tip here keeps when it experiences a change in magnetic field between the tooth and the gap, it keeps cutting power to this LED light inside the sensor. Yet on the other end of the sensor is a phototransistor, which is in there detecting, waiting to see the light from this sensor. So the computer waits, it powers this light, and it powers this sensor, and then it waits to read the signals from this phototransistor. When there is light, this phototransistor will send a signal. When there isn't, there will be no signal, and that change in signal on off will, to the computer via these wires, be an interpretation of the passing teeth and gaps on whatever is rotating in front of this sensor. You will notice that the computer, you ask me that how does the computer know exactly which of these teeth it is seeing, this sensor is seeing. You see this long red tooth here, it's longer than the others, and because it will send a longer signal when it is passing this tip, the computer will take that as the beginning of the cycle, and then count these teeth until it sees this one again, and then at all times after that, after the first rotation, it will work out which tooth exactly is passing, because it knows where this red tooth is, because it sees it, notes where it is, and then begins counting how many have passed. It knows how many, the computer knows how many teeth are on this rotor. That's why you get problems if one or more of these teeth are chipped or broken. You get timing issues. The vehicle may even fail to start. If it starts, it will run very badly, and sometimes it will stall. So that's very important. Also to note is this air gap. There is a minimum. It shouldn't, of course, touch the tip of the sensor shouldn't touch these passing teeth, because there will be breakage, but it should be as close as possible. If it's too far away, the signal might either be very poor or non-existent, and you get timing issues again. Yes, for the magnetic type of sensor, as I mentioned earlier, those don't need power from the computer. They will generate their own power, which they will send to the computer via these terminals of the sensor. And these sensors are usually not polarity sensitive. They will just send a sine wave. It will be a smooth wave like that, whereas those other types of sensors which I mentioned earlier, which need power from the computer and require 3 wires and have 3 connections, 3-wire connections on them, those would generally produce a square wave, because they will be toggling the sensor reference voltage on and off. The sine wave will generate its own voltage, and that will be in form of a sine wave. For the Hall effect type of sensor, the one that requires power, the one that toggles sensor reference voltage on and off, you find 3 wires. When you're testing, if you have a code related to that, you might have got it from anywhere else or brought your vehicle to talk to my car, and we pulled the code of your ECM related to any of those, either CKP or CMP sensor, and sometimes ABS sensors, some of them this type. You have 1 wire as the ground, the other will be the 5-volt reference 5-volt reference wire, which should have 5 volts on it all the time, and the other will be the signal wire. Now, when you're testing this kind of sensor, you should, at this terminal, make sure you have a ground, a 5 volts, and then when you turn the crankshaft, say if you attempt to start the vehicle, you should see 5 volts being toggled on and off. The fluctuations in this kind of voltage may be very difficult to see with a common type of multimeter. The best thing to use in this case is an oscilloscope to check out the quality of signals that this sensor is producing. It is best to use an oscilloscope. Now, beside the knock sensor, which we discussed in another video, if you haven't watched our video on how the knock sensor operates, please try to find it because it's out there. Besides that knock sensor, on some designs, the manufacturer uses the crankshaft or camshaft position sensor to confirm a misfiring engine, because there will be an erratic kind of signal from the crankshaft or reluctor wheel of the camshaft, and when the ACM sees a signal from the knock sensor, it will try to confirm which cylinder is misfiring by looking at the CKP and CMP sensors, because it will try to synchronize when the knock sensor reports a knocking condition and which cylinder is being fired at that time. And that's why when you bring your car to talk to my car, especially for some of the more modern vehicles, you not get just a general misfire code. You get a specific one, say cylinder 2 or 3. If it's a 6-cylinder engine, it might say cylinder 5. It might mention all of them, meaning all of them were misfiring. or just one or two or more of them, depending on what the ECM was seeing from both the CKP, CMP, and NOx sensors. So you need to be aware of that. And I was mentioning to you previously about voltages being toggled. Here is an example. This is from a Hall effect sensor. You get, this is the square wave I was talking about. It comes in form of a block. Basically you have 0 voltage at this level, and then about 4 point something volts on the upper side. So basically what the sensor is doing is toggling this sensor reference voltage on and off. It's off in this section, on in this section, off in that section, on in that section, and so on. Whereas the magnetic type of sensor, the 2-wire sensor, which generates its own voltage, will generate a sine wave similar to an AC kind of. Actually, this is an AC type of wave. It's very important to understand why you need an oscilloscope to check the quality of the signal you're getting from this sensor. I think now with this image you can see the importance of owning an oscilloscope. The common multimeter might not, it will actually not give you a good picture of what's going on, because it will just give you a constant reading of an average of these voltages depending on how the voltages are cycling. It, in this case, it will give you, because this 5 volts is on less time than it's off, it will give you a small constant voltage of about 1 or less. In this will be similar or even less. It might give you something like 0.6 or 0.7 volts. So that's not good enough to work out how good, how well these sensors are working. I hope you understand that limitation of checking signals from these sensors using a simple multimeter. As usual, I prefer to urge you to use wiring diagrams when you're tackling engine management circuits. The example I'm going to use in this video is from a 2003 Jaguar SK type. It's a 4.2 liter engine, V8 engine. That's a really big, powerful engine. Gasoline. And the section from which I picked this image had these other sensors too, oxygen sensors, both upstream and downstream. It has 2 of them because each bank on the V8 engine requires 1, so 4 cylinders will share 1 and 4 cylinders will share the other. And then we have the downstream, that's after the catalytic converter. And then here we have the CKP and camshaft position sensor. In this case, because we are seeing 2 wires in each of these sensors, this means they are magnetic type. And here there is symbol for the reluctor wheels. You can see that it looks like the CKP sensor, because you see more teeth here. It looks like the CKP, the crankshaft reluctor wheel has more teeth than the either camshaft reluctor wheels. And you can also spot that they have included the wiring for you here, what the colors of the wires will be. Once you go to the engine, it will be very easy for you to identify the wires and therefore the sensors. For the crankshaft position sensor, you are looking for a wire with purple and yellow wires, and this one will have a green wire, and then this one will have a blue one and an orange one, and so on and so forth. These oxygen ones have green wires. This one we have a green one and the black one, and usually means neutral, so it's usually black. So this oxygen sensor will have a green wire and a black one, and then and so forth, so on and so forth. I'm just using this to give you an idea of how useful it is to have these wiring diagrams. And on the computer, you'll be able to spot here that they have even included which pins to look out for. When you go to the computer, which pins are coming from which sensor or which actuator. In this case, for the CKP sensor, on the computer, you find the connections are pins 37 and 36, and usually the pin numbers are labeled on the computer, so it's easy for you to spot and make wiring or connectivity checks on the computer itself, because it's easy to spot the wire colors and the terminals at the ECM where you're going to pin your multimeter. Once again, I thank you for your interest in our videos at Talk My Car. We strive to save you time, money, and headaches when you are dealing with vehicle computer diagnostics. Please contact us either at our Facebook group page, which I showed you before, whose URL I showed you before, or via the phone number at the bottom of the screen here, 0414-697-065. Talk to My Car works closely in partnership with SSK Motor Garage in Chalwajala. Thank you for your time in viewing this video. Bye.